Hello and welcome. If you're getting ready for your WAEC, NECO, or JAMB exams, you are in the perfect place. Today, we're tackling a super important topic, a real sure banker in your physics exam, the reflection of light. You see, if you can master what we're about to cover, you'll be able to confidently handle those questions on images, mirrors, and all the applications that, trust me, come out every single year. Okay, are you ready? Let's get right into it. So, here's our game plan for today. We'll kick things off with why this topic is so important. Then we'll get into the two simple laws that govern everything. After that, we'll explore plane and curved mirrors, the ones you see every day. We'll then jump into the formulas for all the calculations, solve some real past questions together, and wrap it all up with a quick summary and some killer exam tips. Let's go. And look, I want you to be confident that your time here is well spent. Everything we're covering today is pulled directly from the official WAEC, NECO, and JAMB syllabus. No fluff, no distractions, just the exact content you need to score those high marks. We're focused. Alright, let's start at the very beginning. Everything we're going to learn about reflection, whether it's from a simple spoon or the headlamp of a car, is built on two very simple but powerful laws. Let's break them down. The first law is as straightforward as it gets. It just says that the angle of incidence is equal to the angle of reflection. Simple, right? The angle of incidence, which we call I, is just the angle that the incoming light ray makes with the normal. And the angle of reflection, R, is the angle the light ray that bounces off makes with that same normal. So, bottom line, I equals R. Always and forever. Now, the second law. It might sound a bit more complex, but trust me, it's really not. Just imagine this screen is a flat piece of paper. This law is just saying that the incoming light ray, the ray that bounces off, and that imaginary line we draw perpendicular to the surface, the normal, all three of them exist on that same flat piece of paper. They're all on the same plane. That's it. And this diagram here just brings it all together perfectly. You can see the angle I and angle R are equal. And you can imagine all those lines drawn on a single flat surface. Now, here's the most important thing to take away. These two laws are universal. It doesn't matter if the surface is a flat mirror in your house or a curved side mirror on a car. These laws always apply. So now that we have the laws down, let's see how they work with actual mirrors. We'll start with the simple plain mirror you probably looked into this morning. And then we'll get into the curved mirrors that we see all around us every day. Okay, just think about the mirror in your bathroom. The image you see has 5 specific characteristics that examiners absolutely love to ask about. 1. The image is virtual. It looks like it's behind the mirror, right? 2. It's erect, meaning it's standing upright. 3. It's the same size as you are. 4. It's laterally inverted. That's why the writing on your t-shirt looks backwards in the mirror. And finally, 5. If you stand 2 meters away from the mirror, your image looks like it's 2 meters behind the mirror. These 5 points, they are pure marks waiting for you in an objective test. Okay, now let's talk about curved mirrors. We've got concave mirrors which curve inwards, like a cave. These ones bring light rays together. They converge them. Think of a makeup mirror that makes your face look bigger. Then you have convex mirrors which bulge outwards. These spread light rays apart. They diverge them. Think about the side mirror of a car that gives you a really wide view. Now, here is a key exam point. A concave mirror can form both real and virtual images. But a convex mirror, listen, it always forms a virtual, upright, and smaller image. Always. Remember that. Alright, it's time to get into the calculations. Now, I know this is the part where some students start to panic. But I promise you, if you just understand this one formula and one other simple rule, these questions will become the easiest marks you will get in your entire exam. Let's do this. This right here is the famous mirror formula. You must know it by heart. 1 over f equals 1 over u plus 1 over v. F is your focal length, u is the distance of the object from the mirror, and v is the distance of the image from the mirror. It's that simple. Go on, memorize it right now. Okay, now pay very close attention. This slide is the secret to your success. This is the sign convention.
Forgetting this is how so many students lose easy marks. Just follow this simple table. The object distance, u, is always positive. Easy. If the image is real, v is positive. If it's virtual, v is negative. And for a focal length, a concave mirror has a positive f, while a convex mirror has a negative f. Master this table, I'm telling you, and you will not fail any calculation question on this topic. Let's apply what we've just learned. Here is a perfect example of a typical exam question. We have an object. It's placed 20 centimeters in front of a concave mirror. The focal length is 10 centimeters. Our job is to find the position, which is v, and the nature of the image. Is it real or is it virtual? Okay, let's solve this together step by step. First things first, we write down our data using our new best friend, the sign convention. Object distance, u, is plus 20 centimeters. Because it's a concave mirror, the focal length f is also positive. So f equals plus 10 centimeters. Good. Step 2, we state the formula. 1 over f equals 1 over u plus 1 over v. Step 3, we just substitute our values in. So 1 over 10 equals 1 over 20 plus 1 over v. Now the only thing left is a little bit of algebra to solve for v. So if you rearrange the equation to make 1 over v the subject, you get 1 over 10 minus 1 over 20. The common denominator is 20, so that gives you 2 minus 1 over 20, which is 1 over 20. Now, if 1 over v equals 1 over 20, then v must be plus 20 centimeters. And this is why the sign convention is so powerful. Because our answer for v is positive, we know two things immediately. The image is located 20 centimeters from the mirror, and its nature is real. The math tells us the whole story. You've learned theory. You've learned the formula. Now it's time to face the real deal. Let's put all this knowledge to the test with real past questions from WAEC, JAMB, and NECO. This is how you build real exam confidence. You've got this. Let's go. Okay, check this question out straight from WAEC. It's a theory question. State the condition for a light ray incident on a concave mirror to reflect through the principal focus. You see, it's not always hard math. This is a simple recall question. The condition is simply this. The incident light ray must be traveling parallel to the principal axis of the mirror. That's it. That's the full answer the examiner is looking for. Simple as that. Now, for a classic JAMB question. This one is beautiful because it tests everything, the formula, the sign convention, and the properties of the image. First, did you spot the little trick? They gave us the radius of curvature, r, is 20 centimeters. You have to remember that focal length, f, is half of that. So f equals r over 2, which is 10 centimeters. Since it's a concave mirror, f is positive. So f equals plus 10 centimeters. The object distance, u, equals plus 15 centimeters. Now we plug it into our formula. 1 over 10 equals 1 over 15 plus 1 over v. Solving for v, we get 1 over 10 minus 1 over 15, which is 1 over 30. So v equals plus 30 centimeters. Since v is positive, the image is real. But is it magnified? Let's check. Magnification in equals negative v over u. That's negative 30 over 15, which gives us negative 2. The size of the magnification is 2, which is bigger than 1, so the image is definitely magnified. The correct option is A, real and magnified. See how we did that? And here's a theory question from NECO, testing if you know the applications. A convex mirror is preferred as a driving mirror because it's... Why do we use them in cars? Let's think about it. We know a convex mirror always forms a smaller or diminished image, so A is wrong. We also know it always forms a virtual image, so C is wrong. So what's the big advantage of the image being smaller? Well, it means the mirror can capture light from a much larger area. In other words, it gives the driver a wide view of view, so they can see more of what is happening behind them. So, the correct answer is B. Woo! We have covered so much today, and you have all done brilliantly. Now, let's just wrap this all up with a powerful summary and some final exam tips that are going to give you that extra edge. Think of this as your cheat sheet for success. Here are the essential formulas from today's class. The law of reflection, I equals R. The mirror formula, 1 over F equals 1 over U plus 1 over V. And the formula for linear magnification, M equals negative V over U. My advice, pause the lesson right here. Write this down in your notebook or just take a screenshot. This is your quick revision guide. Now for some golden advice. Listen up. First, for your theory questions in WAEC or NECO, always try to draw a simple ray diagram. Even if they don't ask for it, it can get you extra marks. Second, and I can't say this enough, master the sign convention. It is the key that unlocks all the calculation problems.
Third, memorize the image properties for plane, concave, and convex mirrors. It's free marks in your objective paper. Fourth, practice drawing your ray diagrams neatly and accurately. They can carry some very heavy marks. And finally, don't throw away marks. Always remember to include your units, centimeters or meters, in your final answers. I want to leave you with these thoughts. Physics can seem tough sometimes, I know, but you absolutely have what it takes to understand it and to do brilliantly in your exams. Believe in yourself. Be consistent with your practice. And I promise you, you will achieve the excellent results that you deserve. If you found this lesson helpful, please do me a quick favor. Like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB, and please subscribe to our channel right now so you don't miss the next topic.